All right, we now know we can save Earth from an asteroid. On September 26, NASA and the rocket scientists from Johns Hopkins Applied Physics Lab successfully crashed a satellite into an asteroid. We were told it was like running a vending machine into a football stadium at 14,000 miles an hour. Not just for fun. No. They wanted to know if it was possible to knock an asteroid off its path toward Earth, should that need ever come up. They called it DART. They still call it DART, the Double Asteroid Redirection Test. And, well, they passed that test, finding out today that crash into that asteroid had a bigger impact than expected. The head-on crash slowed down its orbit by 32 minutes. And with such a successful test, they knew the outcome weeks before they expected to. So we thought we'd check back in with Dr. Harrison Agrusa, the Eagle High grad, who now has to figure out what happens next. For fans of astronomy and pretty much all things celestial, the crash that happened 2 weeks ago had a much bigger impact on science.
Yeah, so this is the first time humanity has measurably altered the orbit of a celestial body, which is super exciting.
That's a pretty cool thing to put on your resume.
Yeah.
Eagle High grad, degree in physics and astrophysics from Berkeley, doctorate from Maryland. Harrison Agrusa already had quite the resume. And now you can add interplanetary defender. Were there a lot of party hats and confetti, high fives? What was the reaction?
Yeah. Well, the first thing is once we detected the new orbit period, that also meant that we detected that Dimorphos was still there, right? So that was where we clapped and cheered, like, oh, thank God we didn't destroy the thing, which, it would be cool, I guess, if it was destroyed, right? It'd make headlines and stuff like that, but it would be bad for a planetary defense test, right? Because if we can't measure the result of the test, then it's useless, right? And if we're going to deflect an asteroid in real life, we don't want to blow the thing to bits because now we just turned one projectile into a shotgun, basically, right?
True. Yeah, it's good you didn't destroy it, but that would have made a pretty cool movie.
Yeah, would have been a cool movie, but yeah, NASA would have been upset with us because it would have been an untestable thing.
The test was to see how much they could change the trajectory of an asteroid. The basic goal was to slow its orbit by about a minute.
But we expected a little bit more than that. So between 10 minutes and maybe 50 minutes. Most people probably thought it'd be more like 10 to 20 minutes.
Okay.
So, right, the 30-minute change wasn't outside of the realm of possibilities, but, a lot of us were, I guess, pleasantly surprised is how I would put it.
Now is when Harrison's work takes off to figure out the new orbital dynamics of Dimorphos.
So now, the pre-impact orbit was this sort of circular thing, and now it's shrunk by 32 minutes. So the orbit's gotten a little smaller. So now Dimorphos is orbiting slightly closer to Didymos than it was before. So the gravity it's feeling from Didymos is a little bit stronger. That orbit is slightly eccentric. So it's no longer this nice circle. It's maybe more of an ellipse. And so what we think might happen, and this is part of my job, is Dimorphos will start wobbling in its orbit as it's orbiting around.
Will that wobble affect future missions to that area of space? Well, that's where Harrison's PhD comes in, sort of. What kind of math have you been doing to figure this all out?
Actually, a lot of it is high school physics, to be honest. I use a lot of basic physics and college physics still, simple conservation of momentum and energy, right? If anyone's listening, if you're in high school, I use that stuff every day. And the funny thing is, I still have to Google it every day. I forget all the time. All those equations that your teachers say, you need to have this memorized. I don't memorize any of it. I'm Googling that stuff every other day. But the concepts I remember, right? It's just the exact formula I forget.
Still know the Pythagorean theorem, by the way. He calls himself a PhD. Harrison says his job will be to figure out why that asteroid slowed down. The orbit did more than expected. Maybe it was heavier than they thought. He also has to figure out the new orbit and its wobble that he talked about, since in 4 years there will be a mission to that space of space, which will help get a clear picture of what that crash did to that asteroid. So his work will help them not be another unintended crash.